as we were saying in the last video, our next section is on parallel and perpendicular, and this is in both Module 6 and Module 7, so we come back to it at a later time as well. So parallel lines, I think most of you probably already know what they look like, but let's go ahead and draw them in. So parallel lines are the same distance apart, and they never cross or intersect. So parallel lines will look like this. And do you agree that they would be the same steepness? If you were going to climb this mountain, it would be the same thing as climbing this mountain. And remember, we learned steepness means slope. So parallel lines have the same slope. And that makes sense when you look at them. Yes, they do have the same steepness. So when we have, based on what we did above on y equals mx plus b, we know the m, the number in front of the x, is the slope. And look at those. Those both have a slope of -2. So that's what it would look like to have parallel lines. The two slopes would be the same. The y-intercepts don't have to be the same. They don't need to cross the y-axis at the same place, but they do need to have the same slope. So if you're given two equations, you can tell before you even graph if the lines are going to be parallel just by comparing their slopes. Perpendicular lines are a whole different ball game. Perpendicular lines cross at right angles. We have perpendicular lines all over the places in our house where our ceiling meets our wall, where two walls meet, where the outside of the house meets the ground. Those are all considered perpendicular lines. And perpendicular lines, if you want to draw a little image here just to remind you, are two lines that intersect at right angles. And that little box is how we designate right angles. Now these have very, very different slopes. They're not the same like on parallel. Their slopes are opposite and reciprocals. And I like to write the word "and" in there because a lot of students think opposite and reciprocal are the same thing. Not true. Opposite means one is plus and one is minus. Reciprocal means if 2/3 is one number, the other number is going to be 3/2. So not only do they have to have different signs, they also have to be reciprocal. And it can't be one or the other. It has to be both. Different signs and reciprocals. And that's why I like to write the word "and" in there. So I've listed some here for you to see. This first equation, y equals 4x plus 1. Does everybody agree the slope is 4, right? It's always what's in front of the x. And on this one, it's -1/4. So let's verify that both things are true. Do they have different signs? Yes. One's positive, one's negative. Are they reciprocals? Yes. One is 4/1, and the other one is 1/4. So both things have to hold true for us to say that they're perpendicular. Here's another one that's a little easier to see. 3/4, positive, -4/3. So when they're fractions, they're easier to see when they're perpendicular. And here's another one, -2, which would be -2/1, and positive 1/2. So one positive, one negative, reciprocals. One positive, one negative, and reciprocals. And this one is kind of a shocker to some students. Once I draw the picture for it, they're like, oh yeah, that makes sense. But we just learned on the other side, think of the ski tricks. No skiing. So undefined is a vertical line. 0 fun. Oh, that's a horizontal line. So what that's saying is every horizontal line is perpendicular to every vertical line. That makes sense, right? Be just like the coordinate plane, the x and y axis. So every horizontal line will be perpendicular to every vertical line because this is vertical we learned on the last page. And this is horizontal. Whenever the slope is 0, it's always a horizontal line. Whenever the slope is undefined, it's always vertical. Okay, so let's put our last section where we solved for y, found the slope, together with this new information and see if we can determine whether lines are parallel, perpendicular, or neither. So if you want to put a little icon up here, or a little reminder, something like that. So parallel would be when their slopes are the same. They have the same steepness. Perpendicular would be when their slopes are opposites and reciprocals. And neither would be like if one was 3 and the other one was -3, for instance. They're different signs, but they're not reciprocals, so they have to be both. So that kind of gives you an idea of what we're looking for. Well, the exercises above, example 2 that we just did on the last video, we learned that if you want to know the slope and y-intercept, you have to solve the line for y. You have to make it look like y equals mx plus b. I can't just look at an equation and go, oh, the slope is blank. Can't tell by just looking. So you have to make all the lines look like this, and then you look at what's in front of the x, and that's how we can decide. And that's the only thing we know about parallel, perpendicular, neither is about their slopes. So that's how you would know to solve for y, because you want to compare their slopes. So this is going to go back to, and we're not going to do example 4, so we can use that room down here. This is going to go back to what we learned in chapter 5. Remember when we were solving for different variables, solving formulas? So if we have x plus y equals 5, and I need to make it look like y equals mx plus b, that means I need to get y alone. So what would I do to get y alone? I don't want to move it. If I need to move this, I have to do the opposite. So the opposite of add x is subtract x. And just like we did above on 2c, don't put the x underneath the 5. They are not like terms. So you don't want to accidentally put it underneath and try and combine those. So opposites cancel and we get y equals, and just like we did on c above, you want to make it look like mx plus b, so let's put the x term first. And remember, when we write it, we carry the sign with it, so that would be negative x. And do you all remember that means it's negative 1x? And then 5 would go next, and it's positive 5. So now it looks like y equals mx plus b. So now I can read the m and read the b. So easily I can tell the slope of this line is -1. So now we need to solve the other line, compare the slopes, then we'll know whether to write same slope, parallel lines, perpendicular lines, or neither. Okay, let's look at the second equation they gave us. 2x plus y equals 5. So remember, this is my goal. Keep your eye on the prize here. I need it to be solved for y so I can read the slope. So if I keep y there, I need to move the x over just like I did on the last one. Again, don't put it underneath the 5. They're not like terms. So 2x minus 2x, gone. And we get y equals negative 2x. So remember, we want our x term first, so keep it with its sign, and then positive 5. So what's the slope of that line? The slope is -2. So here's our two slopes. So now we have to decide. Parallel? Nope, they're not the same. Perpendicular? Nope, they're not reciprocals and they're not opposites. Therefore, this one is a neither. Because the slopes aren't the same, so they can't be parallel. They're not reciprocals and opposites, so they can't be perpendicular. So neither it is. Okay, so this next one, let's go ahead and move it down here since we're kind of running short on room. What was I thinking? So we have 5y equals 2x minus 3, and we have 5x plus 2y equals 1. So same exact thing. We can't tell anything until we get the equation in y equals mx plus b form, which means solve for y. This one's close. Y's almost alone. What would I do to get y alone? This is multiplication, right? So we do the opposite, divide. And just like I told you above, make sure you divide every single term by that 5. You can't just divide 2 of them. How are you going to pick which 2? It's all or nothing. So then we get y equals 2/5 x minus 3/5. And so we can tell this one's slope is 2/5. So that just means a slope. Oops, off the page, Norris. Keep me in line, guys. So the slope of the first line, 2/5. Now we need to find the slope of the second line. So again, I need y alone. Y equals mx plus b. So to get y alone, I'm going to subtract 5x. Subtract 5x, because I always have to do the opposite, remember, when I'm crossing the equal sign. And then we get 5x minus 5x is 0. 2y equals negative 5x plus 1. So y still not quite alone, right? Because this is 2 times y. So I have to do the opposite too. And just like the last one, make sure you divide every single thing by 2. And so what do we have left here? We have y equals negative 5/2 x plus 1/2. So what's the slope of that line? It's looking like negative 5/2, right? So my second slope is negative 5/2. So now's the determinant. Now we have to determine whether they're parallel, perpendicular, or neither. Are they the same? Nope, so they can't be parallel. Are they opposites and reciprocals? Yes. So these two lines are perpendicular. And all that work is required on the test, so make sure you back up your answers with work. The answer is just 1 point. This is 2 points, this is 2 points. You get 1 point for the answer. So you want to make sure you back it up with work to support your decision. Okay, one more. Let's go ahead and look at C. So what do you notice about the first one on C? Yay! It's already solved for y, right? So we can pull the slope right off of that. So the first slope is 2. Done. Oh, I like it, those kind. So this one is gonna take a little bit of work though. So we need to get y alone, which means I need to move the x over here. So the 4x is positive, so I need to do the opposite to move it to the other side. And so I get negative 2y equals negative 4x plus 8. I need to divide everything by negative 2, negative 2, negative 2. Sorry, I'm running into the words there. And I get negative 2 divided by negative 2 is 1. And this is negative 4 divided by negative 2, which will be 2x. And this is positive 8 divided by negative 2, which is negative 4. So look at the slope. 2. Therefore, the lines are parallel.